Hello guys, so let us continue with a series on the basic concepts of chemistry. Today we'll look into the atomic theory proposed by John Dalton. So let's listen to the postulates formulated by Mr. John Dalton. He said that matter consists of indivisible atoms. Secondly, he said that all the atoms of a given element have identical properties including identical mass, but atom of different element differ in mass. So if I take an atom of oxygen, it will have different mass if I compare it to the atom of hydrogen. So hydrogen will have one specific mass and an oxygen atom will have one specific mass. Compounds are formed when atoms of different elements combine in a fixed ratio. The word or the terms fixed ratio are more important while specifying the definition of compounds. We have already seen this in our previous video. And the final postulate given by Mr. John Dalton is chemical reaction involves reorganization of atoms, and these atoms are neither created nor destroyed during a chemical reaction. Now let's move on to the atomic mass. Atomic mass is the mass of an atom. And what is responsible for this mass of an atom? The protons and the neutrons which is present inside the nucleus are responsible for this atomic mass. For example, we take a carbon atom. The number of protons inside a carbon atom is given as 6 and the number of neutrons are also 6. So if we add the number of protons and neutrons, we'll get the atomic mass, and the atomic mass for carbon atom is 12. While writing the element symbolically, we mention the symbol in the center, the atomic number at the top and the atomic mass at the bottom. To be specific, the atomic mass of carbon atom is 12.011. Carbon 12 is assigned a mass of exactly 2 atomic mass unit. So carbon 12 is assigned a mass of exactly 12, not 2, it is exactly 12 atomic mass unit or AMU. This is the point we need to keep in mind. So 1 atomic mass unit is defined as the mass exactly equal to 1/12 of the mass of one carbon 12 atom. So 1 atomic mass unit is equal to 1.66056 into 10 raised to minus 24 grams. Atomic mass unit is replaced by U, which is called as unified mass. For convenience, we use average atomic mass. Now, what is the need for the usage of average atomic mass? There are certain elements who will have a fixed number of electrons and the protons, but the number of neutrons may differ. For example, carbon. Carbon will have, for one particular carbon, it will have 12 the number of protons and neutrons. So the total will be 12. And for some carbon, it will be 14. The total number of protons and neutrons will be 14, which will further impact the mass of that particular atom. So these such kind of elements are called as isotopes. Basically, isotope atoms are same elements that have different numbers of neutrons but the same number of protons and electrons. As explained the example of carbon 12 and carbon 14, the number of protons in carbon 12 is 6 and neutron is also 6, but the number of protons in carbon 14 is 6 and the number of neutrons is 8. Now let's look what is a molecular mass. It is the sum of atomic masses present inside a molecule. If a molecule is given to you, a molecule is a combination of two or more atoms. So you have to calculate the molecular mass using their specific or their individual atomic masses. And if a molecule is having more than two atoms of the same element, then the number of atoms can be multiplied. We shall look at this molecular mass by considering an example of methane. First of all, we multiply the atomic mass of each element by the number of its atom. So for methane, which is CH4, there is 1 carbon atom and 4 hydrogen atom. We know that mass of carbon atom, that is atomic mass, is 12.011 U. So 1 into 12.011 is equal to 12.011 U. Now let's move on to the hydrogen atom. There are all in all 4 hydrogen atoms, and the atomic mass of one hydrogen atom is given as 1.008 U. So 4 multiplied by 1.008 U is equal to 4.032 U. If we add the atomic masses of these individual atoms, then the resulting will be the mass, that is the mass of the entire CH4 methane molecule. This is called as the molecular mass. You can try the example by taking the sucrose molecule and calculating the molecular mass of sucrose. Thank you very much for patient hearing, and if you have any queries, then you can leave them in the comment box.